Okay, so my name's Christopher Clark. I'm a Zen hypervisor engineer. I'm a maintainer of part of Zen and also the Zen recipes in the meta virtualization layer that Bruce Ashfield maintains. Um, and I wanted to talk today a bit about the Zen hypervisor as an example of a virtualization technology you can use with Yocto um, via the meta virtualization layer, and then Tim will talk about some other stuff you can do with the other pieces in meta virtualization. So to give a quick overview of the Zen hypervisor, it's a mature open source project, 17 years at this point, under the now under the Linux Foundation, used in a bunch of different scenarios: server virtualization, cloud, desktop virtualization, embedded, automotive, and it's used to provide strong isolation between the different workloads that you run. So trying to convey in this slide that on an x86 platform, you can run Windows guests alongside Windows guests. And what the Zen project software provides to you is this core hypervisor that's well tested, and the tools that you can run inside a Linux domain 0, where all your virtual machine management, your network management takes place. And it's a very powerful and flexible suite of software. So this what I'm showing on the slide here is a sort of classic configuration. But I work on the OpenXT project that builds a Zen-based system using Yocto and open embedded tools and layers, where we have a more advanced configuration where you can see here there's additional platform virtual machines that are used to encapsulate specific functionality. In particular, we do isolation of the network device driver within a virtual machine so that it's separate from all of your control stack that's running in your DOM0. So Zen's a pretty sophisticated thing. And you can build systems that do this sort of stuff with the Yocto and OE toolchain. So the little project that I've been working on very recently came about through some interest both in the Zen community and in the meta virtualization community for running Zen on a Raspberry Pi. And a number of pieces that had to get worked on to make this thing fly were each coming together with different people collaborating on it. So I set about working on this too to see if we can bring this into meta virtualization as a supportable, maintainable feature that we can carry forward. So the end result is that you will be able to do that if you assemble yourself a system using the following pieces. So we take the Zen support from meta virtualization, the recipes are present there. You add the meta Raspberry Pi layer, which provides you with the BSP support for the Raspberry Pi 4 hardware. We'll be using Pokey and Meta Open Embedded to provide you with the Linux file system and build tools, and then apply a new patch series, which is posted to the meta virtualization list to add the extra functionality that's needed. And then it's a case of doing a classic configuration of a Yocto build by adding a few settings to your local.conf, and then you run Bitbake. And once all of your components have built away, out pops an SD card image. So that's pretty exciting to be able to do it from standard configuration, apply some stuff, bit bake, and out comes our image. So on that image, you have two partitions. This is very similar to the partition layout you would get if you were booting standard Yocto Linux on the Raspberry Pi 4. You've got a boot partition, which in this case has an added hypervisor binary and some slightly different configuration in order to activate that, and then a root file system partition with Pocky Linux. So insert the card, turn on the power, and if you're lucky, this is what you're greeted with. Assuming you have a healthy SD card and your machine's plugged into the monitor correctly, and it makes it all the way through to this screen, which is about as exciting as you can get for a hypervisor engineer. Usually, things tend to present themselves before you get to this point. So the difficulty is it's very difficult to tell this apart from standard booting Pocky Linux. So you log in and then you type XL list, which is the Zen incantation to show you what virtual machines you're running, and there's your domain 0, and you can console yourself that it is actually there and working. So this is not necessarily the most detailed way of understanding what you've just done. So the correct thing to do is to engage use of a serial port. So you can purchase one of these exciting devices for a small amount of money on a popular auction site, and then you plug it into your Raspberry Pi 4. These are the pins that you need. You only need 3 wires to connect, the ground, and then the receive and transmit. And once you've got that and you've plugged your USB end of it into some other machine, you can run the minicom command, and you should be able to see the exciting boot sequence as this thing launches a hypervisor. Oh. Seeing the bootloader take effect. There's Zen's proof of life. You can see the console messages there. And then we're straight into DOM0 Linux. Which is now activating the network. And there you are. So once you're at that point, you can now use standard Zen functionality that you may have some experience with from other systems. You can list your VMs, you can interrogate the hypervisor, check the devices, see the boot messages, all working correctly on a Raspberry Pi 4. So at this point, you've got a hypervisor. You can now use it to run a virtual machine on that host. So let's build a copy of Yocto Linux to run as a guest. So we have a separate image in Meta Virtualization for the guest, which will package Linux kernel drivers suitable for PV devices. And so that will run, and at the end of it, you are presented with the guest file system as a file that is ready to deploy. You also have a kernel image file, and if you then create a small guest config file, which includes the lines here, you are ready to prepare the host for the guest VM, which involves a little bit of a rearranging of your networking so that your guest VM will be able to get an IP address and onto the network when it comes up. And then there's a way of making your disk image available as a loopback device to make it easier for the Zen tool stack to pick it up and present it to a guest. At this point, you can then engage a second exciting boot sequence with the command on the left, which is a standard Zen command for creating a guest. This is me logging in remotely to the Pi, and then on the Pi, creating the guest. So here it is. That's showing you that the guest got its own separate IP address. And I can power it down. And when it's all the way down, I'll be back to the domain 0 command prompt. And do the list to see the running domain 0 and then log out. So in order to make this work with meta virtualization, the patch series introduces quite a few new things using some of the more advanced functionality, I think, than not necessarily used by all layers. We have a new dynamic layer in meta virtualization that will activate when you are using it in conjunction with Meta Raspberry Pi, and that will bring in functionality which is both Zen and Raspberry Pi specific, which includes some Linux kernel patches, some hardware specific configuration, a new bootloader script. It'll configure Zen to build specifically for the Raspberry Pi 4 hardware, and it will adjust the SD card class to include the Zen binary on the first partition. There's also some bug fixes because Yocto uses a very new version of GCC, which not even upstream Zen has quite compatibility with yet. So they're patched for the spin locks to make that work. And there's a couple of other minor things too. So that's making its way through the review process for admission into meta virtualization at the moment. So once you've decided that actually running it on a Raspberry Pi is pretty good, and you'd like to do it on some other hardware, there are some other options for things you can do. You can run it on standard x86 64 Intel platform. That's what we do in the OpenXT project. Meta virtualization has support for building a bootable disk image using the wick command, and then you can just simply DD that to the your hard drive and boot it. It's quite simple and efficient. PC Engine's APU2 is quite an exciting piece of hardware that can run Zen as well using meta virtualization. This one's exciting because it supports DRTM, which the OpenXT community cares about quite a bit. And then the final option I'd like to mention is you can actually run Zen within QEMU at your prompt with the run QEMU command. It is slightly experimental, but I have had it working with earlier versions of the meta virtualization and the standard OE layers, but it definitely exercises quite a bit of complicated code, so that might need a bit of work, but it's definitely close if it's not working already. And that's it. I'd like to say thanks very much for invite me here. And thanks to all the people in the Zen community, the Yocto and Open Embedded communities at OpenXT and Raspberry Pi who've made all this sort of collection of things work together. It's been quite exciting to see the interest, and thanks out to these people for helping with it. Corey Minyard's post to Meta Virtualization list was excellent. Definitely worth noting. That was a strong contribution. Thank you. Okay. Any questions?
And I think once you guys do questions in Slack, and I'll take over now, and then hopefully we'll have a little bit of time at the end still. I don't have very much to cover, so.
Go for it.
Okay, I see direct disk referred to when it comes to image. That's the name of part of the WIC tool. I don't know if it's a WIC class or a script. I have to look through and find it in the source tree. But I think it's a Python class. I remember when I implemented it, right, to make it specifically able to launch Zen, you have to implement a Python class that knows how to do the partition layout. And then I think you also supply a bootloader configuration. And I think there's a default in the Python class if you don't. So direct disk without the -zen suffix will give you a sort of PC BIOS bootable disk image that you can DD for launching Linux. And then direct disk Zen is sort of the Zen variant, which will instead, launch Zen and then launch Linux as your DOM 0.
All right, Chris, I'm going to get going.
Yep.
So, yeah, so I work for Intel Corporation. I'm the Yocto project architect for Intel. And also I want to thank Francois Dugast. He and I worked together on some of the content that you see here. Was intended to be released publicly in a different format, but we weren't able to do that just yet. Whoops. So everything that we're presenting, or that I'm presenting here, is actually up here on this GitLab, and it's going through continuous integration. So there's a lot of stuff there. I'm using GitLab CI Runner with costs. And so if you are interested in that stuff, this is a good place to go look at a somewhat complicated setup. So I'm going to talk about the KVM hypervisor. So this is the hypervisor that's built into the Linux kernel. It's not a type 1 hypervisor. It's not bare metal. It's type 2. So it runs on top of your existing OS. And it's basically QEMU if you think about it. So what you want to do is you want to have libvirt and QEMU installed into your image, right? This is what you need, and you need some special stuff in the kernel, obviously, but it really doesn't take that much to do this. And with Meta Virtualization, that layer has support for all this stuff in there, and it works pretty well. So let's do this. What do we need to do? Well, I'm going to very much shorten down what I would have had. I have a lot more material than this. It'll eventually be posted. But the first thing I wanted is just a package group that adds what I need to an image, right? So I need QEMU built for the target. I need libvirt. And then I want libvirt D and versh there, because eventually I'm going to, automate how the guest is actually launched. It's not quite there yet, but this is the standard way of using KVM images or KVM guests. So I'm not really doing anything different. It's just that it's built with Yocto. So a trick that Ross Burton did back with the Meta Acorn project, which I'll talk about that a little bit later, is to actually take a built image and wrap it into a package. And so I've taken that exact idea, but here I'm using just a binary already built cloud image, and I'm going to install it into where it's expected to be by libvirt, which is varlib libvirt images. And I'm going to do install depend on libvirt to make sure that that directory is existing and that it's going to work. And then I'm just going to take that payload and I'm going to install it into that direction or that directory. So this now would create an RPM or IPAC or whatever kind of packaging you're doing that will install this image or in this guest. So here's an example of an actual recipe. So this is an Ubuntu KVM cloud image. And so I am literally downloading a current, as of the most recent, right now, cloud image from Ubuntu, and then I'm going to package it. So a little bit more in here. A little trick also from Ross. Ross has been a fantastic person to work with and lots of inspiration, is to actually create the checksum live, right, as the image is being built. And so this is just a little bit of a trick here so that I'm always fetching the most current image and it's always being checksummed properly. Whoops, so sorry, I need to switch to my video. So I apologize, I just got this capture device working and just started using OBS today. So I realize you can't read this very well, but this is me already logged into the image that was built. So I'm now going to launch QEMU. And sorry for the keyboard loudness, but this is booting now in KVM. This is booting a cloud image directly from Ubuntu. I did nothing, nothing at all to this image. It is booting right away, okay? Now, there's a lot more that should be done, but this just shows you that I can take an unaltered, untouched image that is ready for KVM and boot it. Now, there's a lot of things like I said, I need to do, right? I need to be dealing with memory and cores and other things like that. I really want SSH keys into this and be able to log in and all those kind of things, okay? And then I did Control A X or Control XA, whichever way it is, to exit the QEMU, okay? So future work, I'm working on it now already, but is to actually enable secure boot, to use Virsh, and actually using a template to create the XML that Virsh wants. And this will actually make it such that the guest is actually fully ready to launch in a configured way on the target. A launch script that will automatically load or launch that guest on boot. And then, like I said, inserting the SSH keys. So you might ask, why on earth am I downloading a cloud guest and installing it? And the reason is that I have worked in a lot of my career on air-gapped systems, military systems that have zero connectivity once they boot. And I don't want to give up virtualization and containers and things like that just because I don't have the ability to get out to the web or get to a registry or something. And so I always approach things in this classic embedded way. I also had a lot more content, including Meta Acorn, the Acorn hypervisor. It's another type of type 1 hypervisor, bare metal hypervisor. And I also have a lot of stuff about secure boot even some stuff about libvirt that was mentioned earlier. And I've got a lot of stuff here about KVM and so on to talk about. But you know, the slides are up, the video is up, and you're welcome to go and look at this GitLab instance and see how I'm doing all of this stuff. So with that, I'm going to stop talking and we'll take questions.